Well, good afternoon, everybody. In 2012, there was a big bang in AI when Jeff Hinton and some colleagues renewed, reintroduced, and refurbished an old AI process called neural nets and called it deep learning. And in the 10 years since then, a group of little companies in America and some companies in China as well grew enormous businesses by offering us products and services which are quite often simply miraculous. So Francis and Juan have asked me to speculate about what AI will do for us in the next 10 years and to raise what may well be some of the challenges in that process. And I'll do that by describing what AI actually is. There's a surprising amount of controversy about that, putting it in context, its historical context, and talking about what the fundamental driver is. And then we'll look at three specific product areas. I like to call them our friends, our phones, cars, and robots, and two industries, two worlds, healthcare and Metaverse, and then talk about where we'll be in 2032 and make some specific comments about Europe. Third time lucky. So, artificial intelligence, two words. Intelligence, my favorite definition of intelligence is goal-oriented adaptive behavior. Nice, short, four-word definition. An entity is intelligent if it has a goal, or has a number of goals, and adapts its behavior to improve its performance in achieving that goal as it proceeds. And the artificial bit is quite a bit easier, actually. Anything artificial is simply made by humans, or possibly by aliens, and not by evolution or by God. The AIs we have today, some of them are superhuman in narrow respect. So they may be the best chess players in the world, much better than any human could ever be. And some of them are quite general in a limited way. So AlphaGo could only play Go, couldn't do anything else at all. AlphaZero, its successor, taught itself how to be the best chess player in the world in one day, and it taught itself how to do that. So general in a limited way, but we don't yet have, and won't have for quite some time probably, artificial general intelligence, which is an AI that has all the cognitive abilities of an adult human. We don't know for sure that we ever will have that, but we probably will, and as soon as we do, it will very quickly become a superintelligence. So we call the AIs we have today narrow AI or weak AI. Something else we don't know is what's the relationship between intelligence and consciousness. We don't know whether consciousness is simply an emergent property of a sufficiently sophisticated level of intelligence. And maybe by developing advanced AIs, we will find that out. So a little bit of history. This gentleman is Hephaestus. He was known as Vulcan by the Romans, and he was the god's blacksmith. He made some really nifty military equipment for the gods. For humanity, he made Pandora, the first woman, so that was pretty cool. And for himself, he made an army of little robots to do some of his work for him, so probably the first example in history of automation. But in the real world, artificial intelligence got started in 1956 at a conference in Dartmouth, in America, obviously. And these are some of the people who were there, and not for the last time, they were extremely over-optimistic about what they would achieve in the next few years. Back then, neural networks was the great hope, or one of the great hopes, and they were called perceptrons. But fairly quickly, it became clear they were limited, and the consensus grew that they were not the way forward. And so people concentrated on another type of intelligence, another type of AI called symbolic AI, in which the idea is to reduce all the concepts, all the processes that humans' minds use to symbols, words and numbers, intelligible to machines. This also had its limits, got its height really in the expert systems in the 1980s, but it didn't fulfill its promise, and as a result, there were a couple of AI winters during which it was impossible for AI researchers to raise funds. That ended. There hasn't been an AI winter since the Big Bang in 2012. Deep learning is a bit like the way the human mind works. It works in layers. It processes data in layers. So each layer takes some input, processes it, passes it up to the next layer. And the difference between this and early forms of neural networks is really the number of layers. And as I say, it's similar to the way a human mind works, or a lot of what the human mind does, but you shouldn't press that analogy too far. Today's best AI systems would probably require enough compute to fill this room, and they require the energy of a small city, whereas your brains, which are much more competent, much more capable, fit inside your skulls and use the energy of a light bulb. But they are impressive systems, modern AIs. They are creative, they can create things from new, and they learn. That's what it says on the tin. They are better at recognizing faces than you are, and they are probably a little bit better at recognizing speech than you are. And they are catching us up in natural language processing, which is when you ingest some information in natural language, process it in some way, and then give back a result in natural language. The reason why we're not going to have any more AI winters, I believe, some people think we will, I don't think we will, is that AI now makes money. It makes a lot of money. Google and Facebook have essentially stolen the advertising industry from Rupert Murdoch, and some people think that's a bad idea. Personally, I think it's quite a good idea. And so it makes money, it's going to carry on improving. The Big Bang that happened in 2012 is fairly well known, but what's less well known is that there was probably a second Big Bang in 2017, when a paper was published by some Google researchers called Attention is All You Need, and that introduced the concept of transformer AIs. Nothing to do with these guys, fortunately. Transformer AIs predict the next token in a sequence. That's pretty much all they do. And the token can be a word, or a part of a word, or it can be an image, or it can be a sequence of code. We have all become aware of them, although we may not know the name, because of these photorealistic images that the latest models are capable of producing based on a simple instruction from a human. So this is GPT-3's picture produced, given the instruction, 2 teddy bears underwater playing with 1970s computer equipment. These things are really quite extraordinary. That was GPT-3, which had 175 billion parameters, and a parameter is analogous to a synapse in a human brain. It's where the neurons meet. And GPT-4 is probably going to be released next month, or maybe January, and it's about 600 times bigger, so 100 trillion parameters. There is, I think, a paradox in AI at the moment. Those examples show how AI research is galloping ahead in the big tech firms and in universities to a lesser extent. Quite extraordinary discoveries and breakthroughs being announced every week. And some of the people I talk to who are working with these systems are revising down sharply their timelines for when artificial general intelligence is going to arrive. And some of them are really quite concerned about it. In industry and in government, deployment is a lot slower. And this is a bit odd. It's a bit of a paradox. And I think there's 2 main reasons. One is that as well as massive compute power, lots of energy, and lots of data, you also need very smart AI practitioners to wrangle the algorithms. And those people are very well paid, and they can be very picky about where they work. And they like to work with each other, and they're typically found in the big tech companies. So that's where they go. But I think there's another reason which is even more important, which is in order to work well, these systems have to learn. They learn, that's what they do. In order to learn, they have to make mistakes. Now, if you're the CTO of BP or CFO of BP, you do not want to implement a system to run an important process in a refinery if you know it's going to make mistakes. You know, you can do all sorts of investigations, but when push comes to shove, you'll say no. And I think that's probably the main reason why there is this apparent divergence. The underlying driver for why all this is happening is Moore's law. It's the exponential growth in the power of the computers we have available. You probably all know that the smartphone in your pocket has more compute power than NASA had when they sent Neil Armstrong to the moon. And that's true, but it's way out of date. I don't know what the latest thing is, but a couple of years ago, I was told that that amount of compute power is now what runs a toaster. And to me, that just means that Neil Armstrong and the others were ridiculously brave people. Because I don't know about you, but I would not want to go to the moon and back based on the intelligence of a toaster. Moore's law is the name that we give to this exponential growth in compute power. Gordon Moore was one of the co-founders of Intel, and he published a paper in 1967 when he realized that the company he then worked for, Fairchild Semiconductors, was putting twice as many transistors on a chip every year. Then later on he realized it was every 18 months, and then clock speed got added to the mix. You will hear it said that Moore's law is dead or dying. It's not. It's evolving. Maybe we should give it a new name, but something like Moore's law is continuing. It's continuing because we don't just stick more transistors on a chip. We evolve the architecture of chips as well. So somebody earlier mentioned that we moved from CPUs to GPUs and then to TPUs, which are optimized for AI. There are also 3D chips being developed and neuromorphic chips. And of course, sooner or later, maybe somebody will tell us exactly when, but probably not, we will have quantum computing as well. So Moore's law or something like it is continuing. There is plenty more. And that gives us this growth in availability of compute power. Not enough people are thinking about this. We are woefully unprepared for what's coming. If Moore's law or something like it continues, then in 10 years, the machines we have will be 100 times more powerful than the machines we have today. That's colossal. But 10 years after that, they'll be 10,000 times more powerful. And in 30 years, they'll be 1 million times more powerful. In that time frame, astonishing things are going to happen. So 3 product areas, which are going to change dramatically in the next 10 years because of all this. We'll start with phones. At the moment, Siri and Siri's friends, Alexa, Cortana, or whatever Google's calling their one today, they can answer a question, but they can't really sustain a conversation. And thanks to natural language processing, that's changing, and you will start having conversations with your phone. Hopefully, it will be optimized so that it doesn't turn into a raging psychopath like Microsoft's Tay. This gentleman is Blake Lemoine. Blake Lemoine was a Google engineer who was fired because he persisted in saying that a Google system he'd worked on called Lambda had achieved consciousness. It clearly hadn't, and he was sacked for continuing to say it. But what he did is going to become more and more common. More people are going to look at or listen to their device and say, hang on, there's something going on here. This is a smart creature. And eventually, they will be. And eventually, probably, we will have AGI, and then things are really going to get interesting. I think probably within 10 years, we won't any longer be interacting primarily through the internet through our smartphones. We'll be doing it through smart glasses. I suspect that by 2032, we'll see as many smart glasses on city streets as we currently see smartphones. So the next product area is self-driving cars. And as we all know, we should be excited about this because humans kill 1.35 million other humans every year around the world by running them over. If you're between 5 and 24, I think it is, around the world, your most likely chance of dying is through a road accident. Humans are actually pretty good drivers. It's not true that we're not good drivers. We are pretty good, but we do get distracted and we do get tired and sometimes we get drunk or angry and then we cause accidents. And machines don't do that. They don't suffer from those limitations. So to paraphrase Agent Smith from The Matrix, we're sending humans to do a machine's job, and we really should stop doing that. Now, self-driving cars have missed their deadlines numerous times. I'm one of the many people guilty of setting predictions when they would be ready for prime time, and they've blown through that. Ford and Volkswagen have dropped out of the process of developing them. And a lot of people think that actually, it turns out it's really, really hard to do, and we won't have self-driving cars for decades. I think they're wrong. I think they're wrong because Waymo and Cruise, so Waymo is a spin out of Google and Cruise is a division of GM, have got self-driving taxis with members of the public running around in them in Phoenix and San Francisco. And they are going to roll them out slowly to other cities. And it makes a lot of sense to do it slowly. It'd be crazy to do it quickly. Elon Musk's Tesla is doing it from a different angle and taking a slightly riskier approach. And then the third product area I want to talk about, another sort of physical manifestation of software is robots. Oh, sorry, yes, I wanted to just raise, one of the things that self-driving cars does, one of the concerns that it may well raise, when self-driving cars are common in streets all around the world, I think that might be the moment when people start to take seriously the idea that AI is going to lead to joblessness. It's not going to happen anytime soon. I think it's probably 20, 30 years away. But if machines keep getting better and better, they will get to a point where they can do pretty much anything we can do for money. We'd better have sorted out in advance what the economy should look like in which robots do all the work and we have fun. I think it's possible, but we have very little idea how to do it at the moment. And self-driving cars could be the thing that raises that to the top of the agenda. The word robot comes from a 1920 play written by a Czech playwright called Karel Čapek. He got the word from a Slavic word which means forced labor, so make of that what you will. Unfortunately, in RUR, the robots rise and kill the human masters. 7 years ago, there was a DARPA Grand Challenge of robotics, and this was the typical result. They just kept falling over. And now, robots from Boston Dynamics and others can dance much better than I can. I will confess that these days that's not setting a very high bar. If you haven't seen it, I highly recommend the film, the short video, Do You Love Me? Boston Dynamics, Do You Love Me? It's a brilliant dance movie. I think it's quite possible by 2032 we'll have the first lights-out factory or warehouse. Amazon is working hard to achieve this. A factory where there aren't any humans working, it's all robots, and so there's no need to have any lights on. Robots that we call drones are making headlines in Ukraine, and I think drones may well be the first widespread form of lethal autonomous weapon systems, which everybody wants not to happen, and probably will happen, and we need to be thinking a lot more about this as well. So robots raise this serious concern about our AI future. And good old Elon Musk, love him or loathe him, he's making it harder and harder to love him. He thinks that humanoid robots will be a much bigger product line for Tesla than cars within some time period, and he calls them Optimus. And he's got a track record of making quite extraordinary things happen, even though he's usually a little bit over-optimistic about the timelines. So that was 3 product areas and some of the concerns that they raise about AI. Let's have a look at a couple of industries, a couple of worlds. First is healthcare. So monitoring devices like Apple Watch, Oura Rings, Fitbits have been around for quite a while. They get better and better every year. And they will do, increasingly, a couple of very interesting things. Eric Topol, a doctor, a very prestigious doctor who's made quite a good career out of being rude to other doctors, says that we will get to a point where doctors are no longer sort of sages that we all have to bow down to and listen to and do exactly what they say. We will give them data, we'll give them information about ourselves rather than going to them for the information, and they will become coaches, and we will become the CEOs of our own health. And we could finally turn healthcare into healthcare and stop it being sick care, which would be a great thing. And in case you're wondering, the best place to put a monitoring device? In the ear or in the rear? Meet Alexander Javronkov, who's from Latvia, not from Russia. He is the founder and CEO of In Silico Medicine, which is one of a number of companies developing drugs using AI. And his 3-stage process has proved beyond question that if you use AI to develop drugs, you can do it much, much more cheaply, much more quickly, and with much less risk. So he's developed a drug, and I'll get this wrong, it's for idiopathic pulmonary fibrosis, yay, which is now in clinical trials. And he did it in 18 months and for a few million quid, whereas normally it takes over a decade and billions, and 90% of drugs that make it to clinical tests don't work. The super tankers that we call drug companies are trying to adopt this, but it's going to be quite a slow process. But when they do, the benefits will be enormous. At the same time, AI is making basic science discoveries. AlphaFold, a system developed by DeepMind, owned by Google, has worked out the folding behavior of 200 million proteins, which is pretty much all the basic building blocks of life on Earth. Ray Kurzweil, probably one of the world's most famous futurists, has been saying for a very long time that by 2029 we'll have something called longevity escape velocity, which means every year that passes, you get a bit older, but medical science gives you a year back, which means you don't actually get any older, which means death is kind of permanently postponed. And as the science gets better, then we can rewind our age. Now, Kurzweil is quite controversial. A lot of people think he's crazy. I think personally his timelines are usually a bit late, but he often does get things right. Last week I spoke to the chap who invented the term longevity escape velocity, a man called Aubrey de Grey, who I understand has been here. And Aubrey is now increasingly optimistic about LEV. He thinks it may happen in 2015, but what he thinks will happen 3 years from now is that we'll have laboratory proof that it's possible in the form of therapies for mice. Now, mice don't live long enough to have LEV applied to them, but you can take a middle-aged mouse, say 2-year-old mouse, and give it an extra year of life. And if we can do that, using the therapies that can be applied to humans, humans are going to start waking up. It's going to be on the Oprah Winfrey Show. When the world realizes that actually we might all live to 1,000 years old, or maybe our kids will live to 1,000 years old. That is going to be an earthquake. And an awful lot of people are not going to be happy about it. A lot of people will say, hey, you're playing God, or this is just a rich man's fetish, or you're going to overpopulate the earth. And I think there's going to be the mother of all culture wars about this, and we're not talking about it yet. I'm quickly going to dash through the metaverse, the second industry, which is an age-old concept, the idea that humans will live in simulated worlds. And it's in the news at the moment because last October, Mark Zuckerberg publicly pinned the future of Facebook on it and renamed his company as Meta. And the reason why he's done that is he thinks that smart glasses are just about ready. The technology is just about ready for portable devices which can track motion in the real world. And so smart glasses can replace smartphones. He really, really wants to be a player in that ecosystem. The part of Facebook, part of Meta, which is developing, it's called Reality Labs. They spend about 20% of Facebook's total expenditure. People who work in it say that his resolve, his focus on the project is so fierce, it's like working under the eye of Lord Sauron from Lord of the Rings. And we don't yet know when it will be that many people will have smart glasses, but as I say, I think probably by 2032 they'll be pretty common. It's worth trying to disentangle. Actually, you know what? I'm going to save us some time. I'm going to nip through these. You all know what virtual reality and augmented reality and digital twins and the blockchain and Web 3.0, you know all that anyway, don't you? So we won't do any of that. Just to say, because I'm looking at the concerns that these things raise, every new medium has a moral panic. Somebody asked earlier, why are we worrying about the ethics of the technologies we're developing at the moment where we didn't in the past? I don't think that's true. I think that we have always worried about new technologies and new media. Socrates, 2,500 years ago, said that writing should be banned because it meant people would lose their memories. The printing press, when it came out a couple of thousand years later, was very strongly opposed by the Catholic Church and others. Radio, TV, telephones, the internet, video games, there's a moral panic about all of them. And there will be moral panic about the metaverse as well. People will worry that Facebook's going to control it, which it isn't. There's going to be a lot of different platforms, and they'll either be walled gardens or more likely an open system. People will worry that a lot of people will disappear into the metaverse and never be seen again, and these people are called teenagers. But actually, they'll be hanging out with their friends. You know, we've been programmed by hundreds of thousands of years of evolution to be intensely social, and a couple of decades of a technology isn't going to change that. And they're worried about the digital divide, that there'll just be some rich people who've got access to virtual reality and the metaverse, and everybody else won't be part of the digerati and will be left behind. This doesn't always go down very well, but I always reply to that by saying, well, where's the fridge divide? Where's the smartphone divide? If a technology works, if it's effective, then companies will make a lot more money supplying affordable versions to everybody than by supplying a few diamond-encrusted versions to oligarchs and celebrities. There are some things to worry about the metaverse. Privacy is a concern which AI and the internet have already raised, and the metaverse is going to aggravate it. And so there are things to worry about, but there's also a lot more concerns than there need to be. So I'm just going to finish by making a couple of comments about Europe, about where we'll be in 2032 and about Europe. The AI that we have in Europe in 2032 will probably mostly not be developed here. It'll be developed by these companies and by their opposite numbers in China, the BAT companies and the Chinese government, which invests very heavily in AI as well. And this is a list of, or a chart of all the great European tech giants. There aren't any. And I think this is a shame. I think it's a problem, because I don't think it's healthy, and I don't think it's wise for humanity's most powerful technology to be a duopoly between America and China. No disrespect to our American and Chinese friends, but Europe, I think, should be playing. And Europe has a lot to offer. It's a very rich part of the world. It has large, well-run companies, and it has fantastic universities churning out great AI researchers who will go off and work for Google and for the Chinese companies. I think really Europe needs to step up its game and take part in this activity. It's had a few possible goes. One was the Human Brain Project, which was really inspirational when it was launched in 2013. The idea was to build a human brain. But it turned out that was a little bit too visionary for a lot of people, and there were academics who feared they weren't getting their share of the budget, and so the visionary founder, Henry Markham, was removed, and he's been pretty much whitewashed out of the story. And the Human Brain Project now, it's still going, and I follow it on Twitter, and I can't understand what they're doing. It's certainly not a visionary moonshot project, which is a shame. That is the kind of thing I think Europe needs to do to get back into, or to get into the AI business. AI is not a race. There is no end point, and it's not winner takes all. AI benefits all of us, whether it's developed in Menlo Park or Malaga. But Europe can and should contribute to it. And it needs to do some quite bold, visionary, and very expensive things if it wants to participate. I hope it does. Thank you.